Yeah, finally. I'm tired of the cold. Really, really tired of the cold. So tonight we have a special guest tonight. We have Joe from Hazelcast and we have Rod Johnson to talk about a really cool agent framework. Embabel, I pronounced it correctly. First, I want to thank Terrace Guy for hosting us. So thank you very much, Terrace Guy. Thanks, Sharon. Where's Sharon? Sharon from Terrace Guy. Thank you, Sharon. Thank you, Lev. And thanks to Hazelcast for the pizza. So thank you, Hazelcast. Yay. Okay, so now most of us are back from DevNexus in Atlanta. We have, how many people has a presentation at DevNexus? So 6 people, okay. And Java 1 was this past week. How many people are Java 1 talks? You watch the videos. They're going to be releasing them over the many months in the future, as I was told. We're prey to the engagement rules, right? What else? Any announcements? Anybody want to make an announcement before we get started with the talks? Any questions about Java? We all know that Java 26 is out, right?
Today I learned you actually can use Markdown now. See Java 23 to Java.com.
You can use Markdown.
Yeah. Instead of free and all this HTML stuff, you can now
use Markdown. Wow.
Instead of
That's helpful. Yeah, that is. It sounds like a nothing, but it's a really cool. Yeah. You write documentation? Yeah. We all like coding, and we're told now with AI, we can now focus on the specs and the documentation. We don't have to do coding. But I like coding. Anyway, okay, so let's turn over to Joe. So Joe Sherwin is a principal solution architect at Hazelcast. Has many years of experience. Do I say the number, Joe? Or it's like over 20 years of experience? I would never say mine because it would it's just too many zeros. And the design, development, and implementation of application systems within multi-tier distributed computing environments, which is a mouthful. So Joe, it's all yours.
Hi, everyone.
Oh, HDMI.
Oh. Yeah.
Small detail.
Yes, right.
Talk amongst yourselves.
Okay, I'm hitting an echo. It's not me. Is it?
Is this going to blow up Zoom? This always does.
Oh. No, it shouldn't.
Turn on the dim screen, the recording will be able to.
Yeah. Sharing is not turned on.
Not permission.
Nothing on the screen.
Watch a movie.
Yeah.
So,
We don't need the presentation. We just watch.
all right. It's always interesting. AV every time. A little housekeeping first. Let me turn this down. Hold on. So if you want to win this prize at the end of the evening, you can scan that code, enter your information, and I'll be doing the drawing. The names will come to me and I'll put it through a randomizer. Not sure, John, $100? Not bad. If anyone wants to do it or wants to go back to that, I'll put it at the end. Let's get to. So what we're talking about today is designing real-time RAG solutions or pipelines in Java and scaling them up. AI is dominating everything. Every topic is about AI, and where does Java play into that? If you're a Java programmer, the question is, how do I design applications in Java? Things like pipelines that drives AI solutions, specifically in this case, retrieval augmented generation solutions. So that's what we'll be talking about quickly. Please, any questions? Please be interactive. And let me. Why most RAG systems are not truly real time? We're going to look at that. We're going to do a quick overview. Oh, excuse me. I got to go back here and pause. Yeah. We're going to do a quick overview of vector search. Vector search is the backbone of RAG applications. The trade-offs between batch and streaming RAG architectures, using streaming pipelines to orchestrate continuous real-time ingestion and embedding generations. Basically, that's ML inferencing, right? So generically. So we're going to look at that and how we can do that using Java APIs. And also, one of the key important capabilities here is how in-memory partition vector storage supports low latency semantic search. Has anyone done any RAG applications? Or, of course. What's your experience with it? Are you using Java? How Python, right? Yeah. Yeah. Why Python? Do you know why Python, or is it like mandated, or? Yeah. Well.
That's in production. We have like a very cool programming language that compiles time and installation. We can find some errors. Of course, yeah. Python and AI is always true.
Yes, that's good. Exactly the kind of banter I was looking for. And yeah, like we're on Java 26, 30 years of Java now. We're still, going strong, but what's really happened is a lot of the new developers are Python developers, right? A lot of the application is defaulting to Python because the models are written in Python. That's really why that they're using Python, but they're using Python for some very complex data structure enrichment and enablement. That's something that's hard to scale in Python. So we're going to take a look at that. And I'm not saying that Java is better. I'm saying, how does Java fit in that ecosystem? For instance, if I have a model that's written in Python, the people who my data analysts or whoever it is who are building these models, why are they concentrating on productionized behavior of Python and not just the model itself? If I can bring the data and call their Python models from a Java application and just put the information, the features or whatever it might be into the proper format that the model is looking for, then that can streamline how we develop and even improve the deployment and the performance of such applications. So RAG is simply a pattern for building AI system, right? So the pattern basically means that I'm using a model that does not 100% rely on the data that it's trained on. It's using data from my domain, okay? Maybe my enterprise, maybe it's new information. So instead, it retrieves the relevant external information and add the context to generate responses, right? Pause there. But so what's the benefits of the pattern? It reduces hallucinations. The model can generate responses based on the latest information, not just stale historical data. It enables use of private enterprise information. One of the interesting things for the company I work for is that it enables the use of information that was generated in real time. So an order was submitted, whether that be a trade on the market, and results come back. I can add that to my embeddings, and any type of queries that's done against my RAG application will now have the latest information to that. So if I'm doing similarity search, for example, on the trading patterns, I can see that information in near real time, and I don't have to wait for it, okay? So basically, vector search, again, is the backbone of RAG applications. So what is vector search? Is everyone familiar? You've heard of vector search? All sorts of new products, vector search databases. Every existing legacy database wants to add this capability to their product, right? So it's basically a method for searching unstructured and structured data. You can vectorize structured data as well. And it uses the ML models to embed, to generate these vectors. Vectors are simply a number of dimensions that are represented numerically. Let me just pause this right here. And basically, most of the calculations in a vector algorithm is doing a nearest neighbor calculation and sending you the relevant information based on your query parameters. So if I have accuracy or specific requirements when I make that query, so I may be querying a legal document, so accuracy may be quite important. I can change those parameters on my query configuration. Any questions on vector search? Yes. Exactly. Yeah. Yeah. So that's read write update of the vectors, yes, in real time. So it's not just the data, but the model may change as well. That's a good point. So if I tell my system the model's changed, you have to go back and regenerate all the vectors for that using that new model. Okay. And I forgot to include the diagram, but there's a diagram or there's a capability I wanted to show was that you can test two different models at the same time, and you can compare the responses of them as you drop that new model into your processing. So with this real-time pipeline, you get a lot of flexibility. You can say use model A, use model B, use both, and you can have different steps in that pipeline. You'll see that the Java API allows you to do that. And then you can sync the results to different places, okay? Or send it back to the requester. So what does a conventional RAG application looks like? Typically, you have a subsystem. Maybe this is your content database. You're grabbing things from the content database. You're generating your embeddings with your model, and you're storing the resulting vectors into some sort of vector DB. And then you have a client that's making a LLM query. You take that query, you vectorize it using the vectors and other configuration against your query parameters. You request a search operation against the vector database. Okay. What, if anything, does anyone know about the vector databases that are available today and popular? Yeah. Yeah. Say again? Yeah, exactly. Yeah. So some of the things is that I have a single instance. You know, if you think of Oracle, traditional RDBMS, it's a single system. I have to scale up the hardware. I may have to run it on specialized hardware. I may have to run multiple instances and find some in the infrastructure between the two instances, Oracle RAC, for example. So it has some limitations for most of the current popular slates of vector databases, right? But what I wanted to concentrate on was this step here. Most of the activity here is batch oriented, right? So even though I'm advertising my system as real-time RAG, the data and my embedding is still based on standard batch operations here. So you get latency between when the information, document, event, whatever it might be, was generated, and when the embeddings are generated and written to the vector database. Depends, right? So if I'm doing a scheduled batch, there might be time scheduled issues. If I'm getting flooded with events, so if it's a real-time activity, this can really flood a system. So I have to store them and then take a batch of them every so often, generate the embeddings and update that. So it could be hours, minutes, and so forth. You know, and in some cases, with my financial clients, what they're doing is they're publishing financial research, and they want to put that in the hands of the portfolio managers as soon as possible. So they're very large PDFs. They're going to take some time to schedule using traditional batch infrastructure and generate those embeddings dynamically and then place it here. So it may not be, I may not be able to act on that information today, maybe tomorrow. And so I lose opportunity with that. It could be micro batched. It doesn't have to be. That's the question. That's what we're challenging with the Kappa architecture that we're suggesting for some of these applications. You know, there are some systems where this is fine, but the other thing about this is that if you don't have this in your environment, this is very expensive. if you're trying to deploy in modern infrastructure, cloud containers, this can also be a problem as well. Any questions? Is anyone doing this, or how do you update your? Say again? Ah, interesting. Okay. Yeah. So what we're proposing is why not apply Kappa, oh, spelled that wrong, Kappa architecture to the process, okay? And does everyone know that Java has a API that can do this type of Kappa behavior? Anyone here use Java util streams? Yeah. So with Java util stream, you're reading a Java collection, right? It's local to the JVM, and you're manipulating it, filtering it. You know, may apply some function to it, but that's basically what this API we're going to look at. It's a Java implemented API, but it's a distributed version of Java util stream. But the connectors can be either in-memory data structures, maps, any collections that are in memory, and in memory meaning it might be distributed. That the map data structure can be distributed and partitioned. Instances of or it might be external. Information might be coming from Kafka. We have connectors, which allows you to listen to and connect to different data sources, whether it's RDBMS, whether it's Hadoop, or you're looking at a file system and waiting for a file to come up. This case, in this example, we're going to do is using the directory watcher connector, dropping an image, and then it's applying the pipeline. The other thing about this pipeline capability that we'll see is that it's parallel, distributed and parallel. Okay. So the embedding can be parallelized. So if I'm actually making, if I'm ingesting and I'm making a call to the ML, I can parallelize that as well on the same machine and a different machine in the cluster. So basically, again, we want to take unstructured, structured data from a source, generate the embedding using a model. It's in Java, it runs into JVM. But this is where we talk about Python, right? And if this model is written in Python, can I still use this Java API to create this pipeline? And the answer is yes. You can actually call in the pipeline. You can call Java models. You can call remote models using gRCP. You can invoke Python locally as well. So you have the ability to have a step where you map using Python or C++ with gRCP. What we do is we take the embeddings and we store it in a distributed collection called the vector collection. So we have the key, which is a key value, the document, and we can set indexes against the collection as well. So generically again, generate the embeddings, whether it's Java or Python, and you store it into the vector collection, and then you can query that collection. So the search engine is part of the API within the vector collection. The indexes, again, when you partition data, so this is stored in partitions. You can go directly to the partitions or the index values across a clustered vector collection data structure.
How does the search engine know which index to pick? Is it using gossip?
So it will know the index you pick based on the your index parameters. So if your index parameters is an attribute of the data, for example, that will be the index it will go to and pick all the relevant information across the cluster. Works similar. So the vector search and storage within HAZOCAS, again, it's partitioned and indexed across clustered instances of HAZOCAS. When your query comes in, it goes to a coordinating instance. Then the query is sent to the specific, to all the members. They aggregate all the relevant index information and return you that value. So your value is the return value is a so your return value is again a set of vectors, which you can then run again through your LLM and through natural language response. Okay. So the other benefit of, I forgot to mention, of vectors is that it's really a nice compact way of storing a lot of information. So if you didn't store a document at all, just with vectors, all you have is a set of floats, right? And that's nicely fits into an in-memory data structure, right? Without having to worry too much about memory issues. Of course, if you want to scale, you can use dynamic scalability. So these partitioning, when I add a node to the HAZOCAS cluster, the partitions are redistributed automatically. So it works well in container environments. So if you want to horizontally scale your solution, you can do that. So one of the reasons why my customers are very interested in this is that they're saying, well, so if HAZOCAS is able to partition the data, horizontally scale dynamically, then maybe I don't need specialized hardware, right? So the latency of having the information in memory, the ability to scale out dynamically, and you can scale it. Since this search, there's a computation is happening, and it's parallelized across the cluster. I can scale up the CPUs, or I can scale out. So now I have less data per node when I do that, right? So it's a very economical way to scale or to implement a rack-based solution. There are some reasons why you might need special hardware, and that has to do with the density of the model. So the model itself may require that you host it on some special software. Again, like I said, your model can be local Java-based model. It can be local Python that I'm invoking. HAZOCAS, actually, each member can invoke multiple Python environments on a machine and parallelize the computation of the calls to the model. But if you have a remote, you're going to OpenAI, you're going to some model hosting service, it can also call out to those as well. So what we're saying is that embedding takes computing power. What you're doing literally is scaling that compute. Hazelcast, the API we're using enables you to do that. Whereas if we go back to that traditional vector DB, it's a single instance, and I have an entire population of the internet hitting my application. How do I scale that to support that? Okay, and now I have to buy multiple instances of that particular vendor database. I have to have some sort of infrastructure to send balance traffic properly. All that is transparent to you with this with Hazelcast and the pipeline. Yeah. So the Hazelcast advantage, with Hazelcast, you can use the pipeline API, you create a job, it runs independent within the Hazelcast cluster. The job is constantly available to generate embeddings. So it's sitting there, even if no data is coming through the data source. You don't have to wait for the entire data set. So you have the ability to search even while the data set is in that area. So you may not have the latest, but you can still send searches to your server. There's some other details. Partition, more partitions equals better performance until partition threads equal the number of partitions. So there are some tuning, obviously, you can do depending on your cluster size and the amount of data and the amount of requests you're getting currently and the amount of data you. It's funny, but we've been testing it. It turns out more partitions actually yields more accurate results. So there's some, so this concept of distributing and partitioning a vector database has some interesting limitation. So you can obviously see that if you're running it in a single machine, you can control, and you have, you're basically using a horsepower of the machine. You can control performance that way with hardware. With Hazelcast, it's a little more finessed, and you have to understand what the best partition value for your cluster would be, for the accuracy you're looking for, and the performance as well. Okay. Again, when we talk about performance in Hazelcast, this is in memory. So it's always going to be somewhat much more performance in terms of the retrieval of the data than the traditional vector data.
How do you know the right stuff's in memory?
So again,
Have this large collection vector stores, it's boundless, right? It's not all fitting in memory. How do you know that the right stuff is in memory at any time that query is being made?
Yeah. So how do you know the right stuff is in memory? Yeah, well, so one of the things we do, right? The job that's running, that's doing that, the pipeline job, can give you information. It can give you statistics. It can tell you, how many messages or files, whatever it might be, that it's processed. It can give you guarantees, processing guarantees as well. So exactly ones and most ones. things like that. So that, and you can also, if you stored a document, you can go back, check it as well.
Right, it's like where I'm getting a little confused. I imagine you want to do a similarity search real time, right? You're only gonna find similar things that are in memory, right?
Correct, yeah.
But that would mean that at some point you would have to make a decision about either I'm taking all of the stuff that's similar to concept A, or all of the stuff that's similar to concept B and gonna stick it in memory. Right, so I don't know how you can be sure that you have the correct set of vectors in memory at any time.
The model is the one that generates the vector. So the model determines the similarity numbers for your data.
Right.
That's not.
But you said what makes you fast is you don't go out to disk, everything's in memory.
Yeah.
Right, that's a lot of memory, like there's huge models, right? So.
It's not the
I'm gonna have
model,
to-
it's the.
I mean, not the model, but the vectors, the amount of vectors I can make.
Yeah, so
I
vectors
can
are
have
like it's.
hundreds of thousands of them. I can have millions of
Yeah, they're
vectors.
just floats. They're
Right.
an array of floats, yeah.
Oh, yeah, a thousand, whatever you want, right?
No, that each.
So you're loading, you're saying, telling me that the entire vector population is stored in memory in the different partitions at all times.
Not the entire, no, it's
Okay.
partition, so it means a partial amount, so.
Right, a partial amounts in there.
Yeah.
So that gets back to my original point. How do I know I'm getting the best response to my query? If you're only looking at what's in memory at any point in time.
Does the cluster have partial vector space, or does the cluster have full vector space? You have partial each
Yeah.
partition.
So when you
That's it.
store your vectors in memory, you have the entire collection available to you. And it's distributed across each member.
Okay, I got it. What he said, yeah, that's good.
Yeah. So it's.
So it is all.
That's what I'm saying, your query goes to every member and it looks for its local information. And then it
Right.
aggregates them and sends it.
And then your ingestion pipeline can grow the partitions.
Yes.
Okay.
So the ingestion pipeline is continually growing, as you add new data. You may say, oh, I want to update this document. I know the key to this document, so I'm overriding the vectors for that particular document.
Right, I got you.
So update in place. The other thing you say, well, read write concurrency, right? If there's an update going on for a key XYZ document, right? We're using partition threads, so you cannot read until that write is complete.
Okay, all right, thank you.
How do you do this concurrency? Because when you update the document, the pre-update version might be in one partition, post-update version might be in another.
Yeah, so when you're writing, you're rewriting the entire partition set for that document.
But I guess what I'm trying
Yeah,
to say
so-
is that you delete effectively
Yes.
of the old vector might be in one partition and insert of a new vector might be in another.
Correct. Yeah, so the vectors, partition, and I may be updating this one while the other ones are not already.
Oh, sorry, I guess, how do you make sure that it is the same cluster members that basically would handle kind of
Yeah, so-
update?
The partitioning is a consistent hash algorithm or algorithm, so we know it always goes to the next vector, unless of course a cluster topology changes, a new member comes in. Again, what we do is redistribute the partitions. And that blocks any kind of operation that's ongoing. So actually it waits for ongoing operation. Any new operation while that partition is being moved is suspended until it's completed.
But each cluster member doesn't have the full partition space, right? So you can still have cluster
Right.
member
If your
A
query,
and its document
yeah,
B
so
partition.
if your query is, so your query goes here, right? And it may hit a subset of these partitions, and they may not be moving, so you can individual query them for you, yes.
You have multiple copies of the data.
Not copies of the data, but partition values of the data. Of the,
But every vector is going to be stored on multiple cluster values in case you lose another. Right?
Again? Oh, so you talking about failures.
Yeah.
So yeah, we have, not only do we have, so each member has a primary set of the data. And then there's for this member, the backups for that primary set is synchronously written and distributed across the other two members and so forth. So it's a RAID system.
You need a way to know if you're writing to the primary, you can't read from the backups. If you're writing to the primary,
Yes, you're writing to the primary, but we're synchronously writing to the backups. By default, you can asynchronous write to the backups, we call it. And you can also read from the backups if you wanted response versus accuracy, yes.
Do you have data skewness problem here as well?
So yeah,
Data skewness problem here as well? The skewness. Skewness.
oh, yes, thank you. It's possible. So you may have a heavy partition, yes. So understanding how you're partitioning the data is it could be very important.
Can you share some lights on that?
Say again?
Can you share some lights on that? How are you handling this optimization?
Well, yeah, so let me be frank, well, how I'm handling it is through design. The design of the vector attributes, and understanding the data that rather than hazel cats and stuff. So yes, you can have a skewness. If I am skewing my data based on Goldman Sachs, then all the indexes are going, and all the Goldman Sachs go into one node on a corporate suite. And Goldman Sachs is my most active customer. It's all goes here, right? So I have to understand that, and I have to find ways to redistribute the data or define the indexes so that they scale up across the maps.
your hash keys are like metadata, not the actual.
You can change your hash keys, you can change how your data is partitioned across the cluster, yeah. So you can do attribute based, you can do different kind of tricks there, to do that. So I may do a trick, because how the queries go across, I remember, but when that just means that most likely I'll hit data on every member and aggregate them as opposed to having them in a single member. Now that may add some network latency to the whole issue. You gotta balance the performance and. So that's why we say, if you have a smaller, you typically have a smaller number of partitions than the default in Hazelcast, you get a better performance because the data is clumped together a little bit.
So when you say that you have more precise results when you have more partitions,
Yes,
that
it takes
only
longer
applies if
because
you
of the
actually
network.
distributing your
Yes.
query across partitions. It's one partition.
Yeah, because now you're going to, you may have a small subset in every partition, but now you're going across the entire cluster every time, rather than one subset.
Do you keep the whole index on every node, or is that partition as well?
So yeah,
You keep the whole index on each.
In memory, yeah.
Is that partition?
yeah, so the index are in memory, and they're replicated across the cluster.
The whole index.
Look at some configurations. And the things I wanted to look at, is to look at the API. And you can see, how I create my vector document. Basically here I'm just, programmatically entering, a vector. I'm doing I can do I can put things into the document async, so I'm not waiting, while that's happening. While that's happening as well. Optimize the index as well. If you're interested in the documentation here, I don't know, if anyone heard of JVectors? JVectors is literally what we're doing. We've productized in the search algorithm, the search computation of the vector collection. Very Java centric. So the other thing is I'm reading from the source and I'm syncing to my vector collection. So my vector collection is just a named object. I can dynamically, programmatically create it. I can configure, use YAML to configure it, and set up the different configurations for that vector. And dimensions and things like that, all kind of affect performance and accuracy of the system. So these, I'm not gonna have time. The example that I was gonna show you here, this demo, it's an image search demo, very simple. Web server, right? Post image files to an endpoint. That it puts the image file into the directory. I have a directory watcher. He goes in, he uses this map using Python, call the Python embedding, set this transformer. And then it syncs the results into the vector collection. So you can see how this has decoupled your ML from your actual application and your pipeline processing. So some other team may have worked on this model here. This model may not be inside Hazelcast, it may be external remote as well. But you're using the pipeline to orchestrate this real-time update of the vector. The other thing I'd like to say is that you don't have to use Hazelcast vector collection. You can actually use a custom connector to connect to a third-party vector DB file. So Hazelcast doesn't necessarily say, hey, use our vector collection as your DB. What we're saying is that you can leverage this pipeline API to actually make your ingestion process built. So one of the other things that happens, right, when I really start pushing this Kappa idea is that if you remember before, a typical RAG application may look like this, using Hazelcast, but then I have a client component here that's also taking in the requests, generating embeddings and making a search operation against my DB, against Hazelcast. If I take this Kappa concept a little further, this is, and I look at this as just as another source of events, the client activity. So literally, client can submit their question in natural language. There's a pipeline that embeds it for it, right? Stores, does the semantic search and returns the results to the client. At the same time, my pipeline that's doing a real-time ingest is also running the system. So this kind of, the ability to do this is where I think we have a game changer for what's the traditional currently with these types of applications. And again, remember, you don't have to use us. You just use our pipeline. You don't have to use this as your DB. You don't have to use Java as your ML models. That can be externalized as well, placed on a special hardware. But we're simply using the pipeline to work at real-time ingestion. Okay.
So what is I guess limits of that implementation? Meaning, to the questions that was asked before.
Yeah.
How much data?
How much data?
And
Yeah.
and actually also the speed of the change of the data can.
Yeah, if you're gonna do sub-millisecond changes. Depending on the model, usually, so depending on the model, whether the model is remote, whether it's local, what compute it takes, to generate the embeddings, that's usually where we see the slowdown, so the performance challenges. But if you parallelize this behavior across multiple machines, you can increase that
Well, I guess my question is, at what point the pluralization becomes a problem? What's that mean?
Well,
You cannot,
yeah, so what we're doing,
Pluralized.
okay, I understand your question. So what we're doing here at the pipeline, so you never even have to worry about CPU or anything like that. The pipeline is using a green thread methodology or implementation in order to not overwhelm your physical hardware. So we're using buffers in between each step in your pipeline in order to not overwhelm any kind of CPU limitations or anything like that. So Hazelcast pipeline is aware of how many CPUs and how concurrent per machine this pipeline can be.
I guess I was asking the not in member pluralization. I mean more pluralization in terms of number of Hazelcast.
Oh, yeah,
Yeah.
there's no limit. So, yeah, so the next thing is how big can your data be? If you're storing data in Hazelcast, obviously, if it's a lot of data, you're gonna have more nodes in Hazelcast. The question about having a big, or the performance issue is, one of the things we wanna make sure is that each Hazelcast member is in the same subnet, that you have at least a 10 gig network between them. We do other things like, yeah, it's a simple, set of floats, but we do other things like compression on the serialization. So the data is actually stored serialized in memory to limit the memory size. And what we see in vectors is not, the memory is not a big problem, is if you're storing the documents as well. And you want to do not only similarity search, lexical search against the document. But yeah, Hazelcast, again, is partitioned. As you add more nodes, you increase your storage there. Absolutely. Thank you.
People are putting AI into production. Only 2 people are putting AI in, 3 people are putting AI.
Define production.
You have user and a manager that yells at you. That's definition of production. So basically 5 people. Those kind of strategies.
Like deterministic system.
Oh, I've been reading these things, but CEOs are saying they're putting AI into production, and they talk to employees and like, actually, we're not.
There's also internal production versus external, right? Like people use something for, an internal help desk, but not for the real customers because that's risky.
And also they do means like, it works with Microsoft Word essentially, and
Hmm.
not in their products.
Or they deployed a chatbot, little production.
Yeah, or it could be the internal CI/CD pipeline,
Yes.
and it's not anywhere at no point do we actually go like, yes, you can actually put it to production. You still have to have a meeting, but everybody
Can you
else.
remind Rod to go into the Zoom? Can you remind Rod to
People
go
like
into the Zoom?
when they talk about production, like
No.
executives, they usually mean it's like that their cell has the chatbot.
Yeah,
Actually.
Yeah. I think I should just record full screen so we get going. Yeah, but I'm gonna record that screen and Rod instead of his screen. Yeah, it's fine. I moved the camera, we're good. Yeah, but I have it on video.
Yeah, it'll be so we all know who Raj is. The creator of Spring, okay, co-founder of Spring Source. I believe you were the CEO, weren't you? Yeah. So, Raj Johnson, everybody.
Thank you. A couple of numbers to come to mind. Last time I spoke to the New York GenAI, I believe was 19 years ago. I'm pretty sure it was 2007. And the Spring Framework version 1.0 GA was released on this day 22 years ago. So, partly what I'd like to convey today is that Spring and Java are still highly relevant. So let's start off with something that Joe touched on early in his talk, which is the question of Python versus Java. There is absolutely no reason that you should be building GenAI AI applications in Python. Because the model's not written in Python. The models are massive things that you get at through a layer of C++ via HTTP. So for anyone who's looked at the APIs of the models, they're incredibly simple. You can use a model, you can drive a model via curl with staggering simplicity. So there is absolutely nothing, firstly, about any single language that is magical in working with models. They are literally about the simplest thing you're ever going to talk to in terms of external systems. So that then brings you to the question of what really does matter. What is the key adjacency? It's not this absolutely trivial HTTP goal. The key adjacency is what you already have. The key adjacency in the enterprise is the systems you already have, the code you already have, the data you've already persisted that's mediated by Spring Data repositories or JVA or all these things that are familiar. So therefore, if you were doing the kind of work that I imagine folk in this room are doing, it is simply crazy to come and introduce a layer of an alien tech that's going to make it way harder to get at your critical business logic just because some ignorant manager thinks that LLMs and Python are kind of the same thing. An interesting example of this is obviously, unless you've been living under a rock, you can't avoid thinking about the lobster. OpenClaw. OpenClaw is not very relevant to us in enterprise, but nevertheless, it's been a sensation. Is OpenClaw written in Python? No, it's not. OpenClaw is written in TypeScript because, again, there's absolutely nothing magical about Python. So this brings me to the motivation of creating Embabel in the first place. So Embabel, if you're not familiar with it, is my new open source Apache license Java agent framework. It is built on top of Spring, so if you're familiar with Spring and Spring Boot, it will be very easy to get to grips with. It's got a pretty substantial and growing community, well over 3,000 stars on GitHub under a year. So, it's going pretty well. And also, by the way, two of the other core developers on Embabel are in New York. Igor is right there, and I know Alex is here. I can't see him, but there he is. There's Alex. So there's also a very strong New York connection with this software. So, what is the motivation of creating Embabel? Well, over the years since creating Spring, becoming CEO, or being CEO, selling the company to VMware, largely going into a business role for a number of years. I was on the board of various companies, including Petrocast, Elastic, Neo Technology. I've worked with a pretty broad range of technologies. Like since then, I've done a lot of Scala, done a lot of TypeScript, a lot of TypeScript and Node, and also a lot of Python. So when we had this amazing moment with GenAI, when suddenly ChatGPT-3 got to be useful and didn't off repeating itself endlessly, obviously having a background of creating frameworks, I thought, wow, this is going to be really interesting to see how we can drive this in business, make it more predictable, make it more useful. So I obviously looked at what was out there in the prior art, and I started writing something in production. Because that was actually, to be perfectly honest, you might find this hard to believe, but in 2023, I was significantly more fluent in Python than I was in Java. I mean, like in terms of muscle memory, like a lot of things I'll just automatically type every day. I fairly quickly came to the conclusion that Python was not the right thing. Firstly, because of the adjacency problem, right? If you are doing this in business, it has to be able to get to the assets and the code and the domain models, etc. you've already got. Why make that hard? Secondly, in terms of building sophisticated applications, Python, while it's very good in some ways, is glaringly deficient in others. Like, whenever I write Python, it did kind of annoy me that I kept running into problems that we literally solved in spring in like 2004. It's like, seriously, this is how you still do this? Like, especially with configuring anything, it's really not, it's very, very good in the small, but it doesn't scale up terribly well in the large. So I guess that what I'm saying with this is I didn't write a JVM framework for GenAI because I think everything should be JVM. I actually, at that time, I would say Java would have been my third most fluent language. I was definitely more fluent at that moment in both Python and TypeScript. And I chose the JVM not because of Spring, not because I was familiar with it, but because I think it's where there is the most value. So this brings us to the question of where the value is with GenAI and why is it very often not found. So, not many people in this room have GenAI in production. Yet I'm sure we're all using Claude or ChatGPT. So we all use it to augment ourselves. In the personal assistant space, there is no question. It's thoroughly proven its value and it works. Whereas in the enterprise space, by and large, it is not proven its value. There are, I think, some very good reasons for this and some very powerful learnings in it. So, anything that involves assistance, and this is a pretty broad category of things. This is like casually, me talking to ChatGPT, asking why this weird looking thing in my laundry is making a horrible noise. And like, I didn't even know what it was. I now know more than I want to know about sewage checkers. But that was really useful. It was, I gave it a photo and it's like, yeah. Or when it's coding, when it's a coding agent, and I use Claude Code extensively, and I'm sure we all use coding agents, there's something in common with all these scenarios. That is us. They're very much human in the loop. So if something goes wrong, you can ignore it. In fact, we have this unbelievable superpower as developers that most of the rest of the world doesn't know about, and it's called version control. If you do something and it really didn't work out, you know what? Nobody ever has to know about it. It literally never existed. All those changes get magically rolled back. So my point is that where GenAI has been extremely effective is where there is significant supervision, where getting it wrong is fine. Like, if you say it gets it badly wrong 5% of the time and totally right, the rest of the time, that's just amazing. I mean, if you're writing code, that's going to really, so long as you know which 5% is the wrong 5%, which is where your value is. But that's going to be unquestionably much better, much faster. In automating business processes in enterprise, not so much, because we like to talk about nines. I've just described one nine. Systems with 1 9, it is basically binary. A system with 1 9 does not work 100% of the time for getting any business value out of it. So, what I wanted to do in creating a framework is attack the reasons that GenAI isn't reliable enough in enterprise. So, the key problem is really non-deterministic, right? So the more responsibility, the larger the prompt, the more responsibility you give to your model, the less predictable the results will be. In some cases, that is fine because you want that autonomy to maximize benefit. You say the agentic coding flow. But unfortunately, it prevents you from automating business processes. So what I will do before I jump into code is briefly describe the things that Embabel brings that I think are different. So very first thing, as I said, there's nothing magical about Python for doing GenAI. I am very familiar with all the Python frameworks. I can tell you they're not great. In fact, I have yet to see a Python framework that is the best, anything like the best Python framework you produce for Python. GenAI framework for Python, let alone the best GenAI framework. Yeah. Overall. So what I wanted to do was not copy, but do something different and innovative. And I think that's what we've done. So firstly, it is based on the idea of attacking non-determinism. To make this stuff useful in enterprise, we've got to make it more predictable. How do we do that? Well, we find the ideal match between code and structure and LLM autonomy. And that involves getting away from the horror show that is euphemistically referred to as prompt engineering. Prompt engineering is basically alchemy. It is like literally throwing things at the wall until you see what sticks, and then you discover that like there's a new model release and now it doesn't work differently, it doesn't work the same. So that is not something that you can build enterprise apps on. So how do you get away from that? Well, what you do is what we've always done as programmers, which is decompose the problem. You break the problem down into smaller steps that you can reason about, and you structure the interaction between those steps. So I wrote a blog a few months ago called Don't Talk English to Your LLM. And I think just because these things are supremely gifted in natural language doesn't mean that that's always the right way to communicate with it. So one of the first things you need to do is to break down longer flows into structured parts and have each part have essentially inputs and outputs that are, in Java terms, data types. So that's one of the core differentiators of Embabel versus other frameworks, is it's very, very much built around the idea of the flow of data types. And this, of course, means that being on the JVM, we have strong typing. This actually can play very nicely with what we have. And also, we have many instances of types that we've already created that we can leverage. So Embabel aims to make it easy to break things down into a natural flow. How would we express natural flow? Well, you know what? Methods are a pretty natural flow. So, we do a lot with enabling Java methods, which do have a contract, right? They've got inputs and outputs, making Java methods a unit of decomposition of these flows. Secondly, you need to have a good way of exchanging types with LLMs. And this is not unique to Embabel. Any framework, even the Python frameworks, will enable you to, say, map identic models to the LLM. And they also advocate this to some degree as a best practice. So typically your interactions with the LLM should not be returning just plain text, unless if it's a chatbot or something like that, sure. But that's typically not what you're doing. What you're doing is getting something back that has a structure and meaning. Get your LLM to return structured things.
Interested in your thoughts. I think one of the key strengths of Spring as a framework is that it's very popular. A lot of people use it. There's a lot of information. It's very easy to find out how to use it and so on. And you could argue that LangChain and friends, occupy that role in the GenAI space. What are your thoughts about not the importance of the language, but the importance of the availability of well-adopted frameworks.
Look, I think it's important, but let's not forget that EJB is very familiar and very well adopted with course Spring.
Says it's very my.
So I think it's an argument build. So bear in mind that Embabel has been away around for far less time, and it's actually during that time it's grown much more rapidly. Secondly, I think once you get to a certain level of community, right, like, you know, if Embabel had 100 stars, that would be an interesting question. But, you know, if you're talking, I don't know, what, 3,000 stars and 12,000, whatever it is, at that point, you've got to ask, well, which one's actually better? And that is definitely the conversation that we, well, so also Embabel, I mean, builds beautifully on Spring, so it's really easy to adopt. So coming back to adding structure, you know, LangChain, okay, I'm going to go there. LangChain for J, by and large, is what its name implies, which is basically, well, we're going to trade on the ubiquity of the Python terminology. Whereas we're much more ambitious than that. We are like, what is the best agent platform you can build in a week? Okay, let's jump in and see how you get started and what the code looks like. So here we have the Embabel agent project on GitHub. Good starting point. Another part that will help with adoption is the documentation, which is really very good. Also, you can download the Embabel guide, which is a RAG application built entirely on Embabel that will allow you to ask questions of the documentation. So, you know, I think that the bar is pretty high these days for open source projects in terms of adoption, and we're doing everything we can to make that easy. And I would strongly encourage, you know, trying the guide as well. So what we're going to do is the very first thing you would do when you get started, which is clone, or sorry, use one of our templates. So how many people here are using Kotlin? And the rest, I assume, are using Java. So basically, yeah, everybody's using Java, some people are using Kotlin. Most of our framework is written in Kotlin, but it is the vast majority of our users are in Java. And we've put a lot of effort into ensuring that the API is really, really nice from Java. It's actually a really interesting thing to do if you're building a Kotlin framework, going the extra mile to make sure it looks beautiful from Java. So if you're using it from Java, you literally wouldn't know it's written in Kotlin. Zero KT companion, you know, anything that's Kotlin weirdness, absolutely not. It will look exactly like Java. And I would actually argue that it's easier to write really beautiful APIs for Java and Kotlin than in Java. Good example of that is the builder. The builder is kind of a useless pattern, but useful pattern, but it's kind of clunky. In Kotlin, because you have copy constructors for data types, we can do loads of withers on our API that don't require the builder stack. So you can create something, you can call a bunch of withers on it, and you don't have to call build. And that is just really easy in the code. Okay, so we're going to assume that we would start by going to the Java agent template. And now we will get our very own project that will look like this. So if we look in the POM, by default, it uses Maven. Obviously, you can use it with Gradle as well. But, you know, this is Spring Boot Maven or Gradle. So we're extending the Spring Boot parent. And all we need to do is put in a couple of Embabel starters, and off we go. So we've got the main agent starter, and we're going to need starters for the particular model families we want, right? Like we don't want to bring in the client code for every model under the sun. So, you know, typically you're going to start off, say, with the OpenAI or in Anthropic starters. So here's, for example, here's the Anthropic starter, and it's totally the same version. Yep.
What's the relationship with Spring and AI?
So currently we sit on top of Spring AI for most model providers, but we are largely independent. Like you can actually work with a model provider that's not supported by Spring AI, and then it's actually a group of very large tech companies that are doing that, where they've got their own bizarre model. It has a bizarre security dance and it wasn't supported by anything else, and they're using Embabel for that. So fundamentally, it is Spring AI compatible, but independent in terms of all the LLMs. What we discovered was that we needed to control the tool calling completely and do some things that are more advanced than other frameworks are doing, which hopefully we will get for. But if you're using Spring AI, you can use Spring AI and Embabel in the same application, and that's fine. Right, so we also have the Spring Shell dependency. So this means that very handy for development. How many people have used Spring Shell? It's actually really cool. The little development time experimentation. So it has come up, and what you'll see from the log output is it's detected a bunch of models, and also it's given you a the reason for this is that I did in Embabel something I'd always wanted to do with Spring, but it was too late to retrofit, which is have logging, info level logging come purely from response to events. This is actually a really, really good discipline, because everything that appears in info level logs can also be streamed over SSE. You can write a listener that handles it. But another benefit of it is we can have what we call our logging personalities. So you can either have a default logging personality, which looks boring and normal, or you can have like Severance for people who like that TV show, Yoda or Star Wars, or you can write your own. It's funny, it's been a little bit polarizing in the community. Most people love it, but a very small number of people just find it baffling and weird. So, but you know what? If you find it baffling and weird, you can always go to application.properties and either change that or omit it, in which case you'll get really boring logging. So this brings us again back to the question about familiarity and adoption. We are very consistent with Spring Boot conventions, so everything is configured using Spring Boot configuration properties. Like this has been so simple, this project has application.properties. In the more complex ones, we have application.yaml, and you can configure everything in a very consistent style. Like you can configure the LLMs you're using, their hyperparameters. So we leverage Spring very heavily. Okay, so now it's up. One of the things that's different about Embabel to other frameworks like LangChain is that Embabel is really designed to run as a server. It's not just something where you call functionality, it's designed to know what capabilities are available on the platform. So for example, here we can ask it, what models does it know about? And it shows us the some OpenAI and Anthropic models. We can also ask it what tools it has, and it'll have a very small number of tools in this one. So it's just got Mac tools and AppleScript tools, which is running on OS X. Obviously, you would connect more MCP or other tools to it for real applications. We can also ask it what agents it has. And here at the bottom, it's got the TLDR, and you can see there's only one agent, which is the write and review agent. So basically, Embabel has the notion of what we call an agent platform that knows about capabilities deployed to it. This is really important because remember I said we want to break things down to individual steps. That brings another question of how do we orchestrate those steps? Right? We probably don't want to do it purely in code with A equals B equals C because these things are error prone, they might need to be retried, and also that's quite inflexible. One way to orchestrate the steps, fairly obvious way, is what, for example, LangGraph uses in Python, which is a state machine. problem with the state machine is firstly, it tends to be quite inflexible. Like, as we know, if you want to change to add an additional state, you've got to do a bunch of rewiring. But secondly, it tends to be anathema to the idea that I mentioned of driving it around types as a key element of the flow. Right, so essentially a state machine would give us something that's orthogonal to the input and output types of the action states. Does that make sense? If you can draw pictures like around your lines around your states, you're actually potentially going to have state transitions that are invalid in terms of the type system. So what we do is something new, which is, as far as I know, a genuine innovation on any platform, which is we use a planning algorithm to look at the potential goal we want to go to and the actions that are available on the platform. So we use a very old non-LLM planning algorithm in order to do this. It's called goal-oriented action planning. That is the name that it was given in the early 2000s when it was kind of discovered in gaming. It's actually an incredibly old algorithm that goes back to the late 1950s. So what it is based around the idea that you've got a goal and you look at all the actions you've got and see if you can create a plan that achieves that goal. Your goal has preconditions that must be met. Your actions all have preconditions and expected post-conditions. So you look at all the actions that you've got and you try to make a plan to the goal. Why is this good? It's good because as you deploy more actions, your system can potentially find better paths. As you deploy more goals, it can learn how to do additional things, and it gives you the ability to extend the capabilities of your system without modifying what you have there. Secondly, the planning step occurs based on world state after every action execution. So an action has preconditions that are absolutely given, right? The action cannot run unless the preconditions are satisfied, and the goal is not satisfied unless they're satisfied. That's a given. However, when you look at the post conditions for an action, it's kind of promises I'll make these side effects. So the planner looks at the world state after every action is executed and then says, okay, I still need to go to this goal. How do I get there? So if something didn't work, or alternatively, if something's changed and there's now a new action available, it might be able to get to the goal in a different manner. So lest this sound complicated, you typically don't have to think very much about Go, because remember I talked about Java methods. Java methods have multiple inputs, 0 or more inputs in their parameters, and they have one output, which is their output type. So what we do by default is convert those to pre and post conditions. So therefore, we can call a bunch of methods to create a final object, chaining them in such a way that they gradually build up everything that's needed. Yes?
Could it scale up to multiple Embabels and across multiple JVM and machines that have different methods and tools and things?
You can federate. We've done a little bit of experimentation around that. As far as I know, everyone in production is probably using a more traditional way of like kicking off the other machine with like something that's going to kick the process.
Yeah.
But yes, you definitely can do that.
Does it mean it allows you to dynamically load agents?
Yep.
And help rewire Go because now new agent is at runtime.
Yes. So it won't during a particular execution, it takes a snapshot because you don't want it to. However, we also have the notion of dynamic conditions that can be evaluated. So and the conditions can change during process execution. Let's get on a bit more with the code before we get into questions. Make sure we don't run out of time. Okay, firstly, you saw the POM, pretty simple POM. Let's do what would be a reasonable thing to do first, which is do the simplest thing you could possibly do with Embabel. So let's suppose your manager said, well, you have to use Python because it's really easy to do GenAI in Python. Let's see how hard it is to do GenAI with Spring Boot. and Embabel. So here we have a very simple record. Records are great, I love them. And it has another nested record inside it. Remember when I talked about types as being really important, very important to return types. Here we have something, this isn't even like any goat flow or anything, there's nothing really complicated about this. This is just a method and it works with the AI interface. Where do we get the AI interface? We got the AI interface because as soon as we have the Embabel starter, we can inject it in any Spring component we want. Once we've got the AI interface, we have a really beautiful Fluent API. Well, I think it's beautiful, which enables us to chain very nicely to create type-safe responses. So in this case, what we're saying, we're choosing an LLM with default LLM. One AI instance can get you into any model you want. So after this, you've got a prompt runner, but you could, for example, specify an LLM by name, you can specify an LLM by role, you could specify an LLM that you'd like serialized, that you can pick it in YAML. Now you're specifying an ID for the call, which makes your logs nicer, saying we're creating an animal. Now, because all of this is strongly typed, we can create examples. How many people are familiar with few-shot learning? So few-shot is a really powerful technique where you give the LLM examples and it improves accuracy. Well, guess what? We have a very strong emphasis on strong typing in general. So now when we say with example, we're not putting in some JSON that might, in our prompt, that might, go out of date. We're literally creating an animal as an example. And then finally, we say from prompt, and the prompt is built within the scope of our method. So you could, like, if you wanted, put in things from your variable values from your scope. Sadly, although modern Java is really quite good, it still doesn't have interpolated strings. That is very, very sad. I was so angry when they took out string template. I changed 300 places in my code and started using Kotlin. But I digress. But fundamentally, you can build this prompt here in a type-safe way. Oh, by the way, with LangChain, the idea of putting prompts in annotations, that is like, you could not think of the worst place to put a prompt in Java if you tried. So, so very simple. Let's see if it works. So we will run it. So we've got a shell command which runs this, and we get some log output, and we got an animal named Glint called Luminox. Why does it have the OX in it? Well, firstly, we had some examples here of a good and bad animal, but actually what really did it was this. We have JSR 386, I think, annotations on this, and this will transparently send that to the LLM under the covers. So, and if the LLM gets it wrong and it fails validation, it'll go back and say, really, you should have OX in it. So even if I take out those few show examples, it still works. So hopefully that gives you, a demonstration of how, for simple things, this compares extremely well. Like the way in which you choose models is really nice. You can externalize those very easily. But now let's look at something that is actually an agent. So we will, when I said agents, there is a single agent, which is a write and review agent. So this is an example of a multi-step flow. So you can see the class is annotated with that agent. That means that it's going to be a multi-step workflow for Embabel. And the agent has two actions. One is craft story. The other is review story. So let's have a look at craft story first. You can see remember what I said about preconditions. So this requires user input. Any of these can call for an AI interface. that's a bit like if you use Spring MVC, you can get these things like the servlet request or whatever. Like they're just kind of there if you need them. But anything that isn't a special Embabel thing is one of the prerequisites of this. So, and what do you think the post condition of this would be? Well, I've got a story. So now let's look at review story. This uses the convenience annotation achieves goal. So and the export means that we can expose it over MCP if we want. You don't need to worry about that for now. But so it achieves this goal, which has a description. And to achieve the goal, you need user input and you need a story, because you can't review a story that doesn't exist. Now, of course, when you're building the prompt, it's completely type safe, right? So we're actually able to use things that we injected with Spring, and we're also able to use the story just building our prompt. By the way, you can externalize prompts using what we call a template renderer. The default implementation of that is Ginger, J-I-N-J-I-A, which is the Python, the default for templates in Python, GenAI. The reason to externalize templates is really one word, it's chatbots. Chatbots, your prompts do get to be sufficiently large that prompt engineering becomes a thing, and you really don't want this much code in Java or Kotlin in your prompt. However, most of the time, remember what I said about prompt engineering, the general impression you would have that I don't like it. You know what? You don't need to worry about prompt engineering. If you're breaking things down into this size of chunk, your prompts are not particularly fragile. They don't need to be tweaked constantly. And therefore, the type safety of having them literally in Java or Kotlin is really, really good. Okay, so now let's have a look. If we looked at our actions here, you can see, for example, craft story. The preconditions are that there's user input. If you look at the review, and it's also going to expect the post conditions that it would have a story. Let's run. So let's say write and review a story about New York's garment district. So it's going to make 2 LLM calls because each of those things makes an LLM call. Let's see, what do we get? We'll get a heartwarming story. And they're disturbingly heartwarming by default. And we'll also get a really nice review of just how wonderful this heartwarming story was. Flickering neon lights. I don't know what it is. That model loves flickering neon lights. So it executed our methods in the right order. And notice there's some interesting things at the end here. Tells you what LLMs were used. In this case, both those calls use the one LLM, but we could have used different LLMs. It tells you the number of tokens it used, and it actually calculates the cost. Because we actually maintain a database of the pricing of common models. You can even get it during the execution of an agent process. You can find out how much this process is consuming and expose it as a tool if you want. So let's move on to I know I need to be a bit aware of time here. Let's move on to a slightly more advanced example. So that's the Java agent template. You can have that running in no time at all. Now let's go to Embabel agent examples, which has a range of slightly more adventurous things. So this has, amongst other things, tool use. How many people are familiar with tool use? Tool use is what makes LLMs useful. Tools can come from various places. They can come from MCP, which is a very common way to expose tools. But more importantly, they can come from your actual code base, where you annotate or otherwise expose tools that you provide to the LLM. That's not unique to Embabel. LangChain4j does it. Spring AI does it. Like all frameworks and every platform do this. Guess what? The framework in Python does it. It's useful to a point. The framework in Java does it. You seriously mean that we can take all the code that we've got and we can choose how to expose functionality for LLMs to use within an agentic callback? That's pretty amazing. So I would actually argue two things. One is that MCP is not that useful in enterprise. And secondly, that in-process Java tools are absolutely amazing in enterprise. Having said that, I'm going to show you an example of use of MCP. But I will also show you how to expose your Java code. So this is a more complex flow. By the way, you might be wondering, how does the shell know how to respond to this text that I'm typing in? We have a convenience for the shell which analyzes the input using an LLM and works out which goal the user is trying to achieve. Obviously, that's not something you typically use in enterprise applications. We have a nice API for exposing the agent platform and kicking off that process of time. So the way you invoke it is usually much more rigorous. So what this is going to do is a number of steps. Firstly, it's going to parse the input text to see if it can find a person's name and star sign. Then it's going to use a REST call to an external API to get that person's horoscope. Then it's going to use an MCP tool to do Brave search to look for current news items that are relevant to that person's horoscope. And finally, it's going to write it up in an interesting way. Okay, so let's see. Today's cosmic mystery remains unsolved. So therefore it feels that, relationship advice, nostalgia, and how to build connections, all of these come from today's news. So let's quickly look at how this works. As you would imagine, it's annotated with @agent. So @agent, by the way, if you're familiar with how Spring works, it's a component annotation. So the Spring annotation's @component is a meta annotation. @agent is annotated with @component. So when you annotate a class with @agent, it says to Spring, hey, inject this as a component, and then Embabel does a bunch of extra stuff. But it totally builds on the Spring component model. Now we've got a number of methods. As we know, the methods are going to have pre and post conditions. So here we've got star person, extract star person from the user input. Star person's got the name and horoscope. So eventually our goal is this. So our goal is writer. Notice pretty much all the calls we do are returning structure. We do have a generate text method, but as I said, generally you want to return structure. So writer takes a star person, it takes relevant news stories, and it takes a horoscope, and then it basically builds a prompt and calls the LLM to do it. This one's being a little cleverer and saying, okay, use whichever of these LLMs you can find in order. We've also made it a bit more creative by setting the hyperparameters here with temperature. As I said, we have a very, very nice fluent API. With top K, all of these kind of things that you'll be familiar with if you know how LLM hyperparameters work, we can do them very, very fluently. Notice, by the way, we don't have the builder noise. So you can set all of that, for example, with Spring AI as well, if you want to go through, a layer of builders. So I think our API compares very, very nicely. So how do we get all these things that we need? Let's look at how do we get relevant news stories. So this is the relevant news stories action. So find news stories, star person, horoscope, and we've got a prompt here, and we say with tool group web. So this says if you've got web tools on the platform, expose this. Tools are very, very important part of the story of breaking things up into structure. So when you break things up, you get well-defined types, inputs, and outputs. This is really important because it means you've got much better explainability. It means you've got much smaller prompts, but also it means you can have focused tools. So for example, when we are parsing the person to find out what their name and star sign is, we don't need a web search, right? That can be done by general knowledge. When we're doing the horoscope, we don't even need to use an LLM at all. So where do we get the horoscope from? Let me retrieve horoscope. Here's an action. Guess what? This action doesn't use an LLM at all. This action uses a service that was injected by Spring. So it also makes it very easy to integrate. Notice the difference. You could say, sure, well, I can just give it a horoscope tool and the LLM will do it. And for a relatively simple case like this, it will. But this way, we can prove what order it will do it in every single time. And that, I think, is what makes the difference for business processes.
You get like all the hotel traceability and stuff
Yep,
in the Spring.
Yep, we've got all the Spring hotel traceability and some high level stuff of our own. And that actually, again, if your manager is telling you you've got to do stuff in Python for GenAI, if you show them how unbelievably good observability is for free on the Java stack versus Python for GenAI, I think will probably blow their mind.
Do you have evaluation as part of this?
Sorry?
Evaluation.
Evaluation, we do have an evaluation framework. It's kind of fairly early on. But you can also, use things like Ragas or other evaluation frameworks.
I'm wondering, what is the purpose of evaluation if you can get more deterministic out?
It depends on the class of problem. Yes, in many cases you can really make it very, very deterministic or as close as you get to it. The evaluation is principally a value for coarser grained things like chatbots. With the best will in the world, you cannot get away from prompt engineering the chatbots. So that's where evaluation. So our evaluation framework enables you, for example, to evaluate conversation flow in chatbots. Okay, so before I get kicked out, I just want to make a few other points about things that I think are genuinely innovative in both. One of them is RAG, which we already heard about. So, I really like the idea of what you're doing with ingestion. On the inference side, however, that's where we've mainly focused, and I think we do some things that are really cool. I would argue that in many cases, simple vector search doesn't work very well. 2 years ago, everyone was incredibly excited. They wrote these blogs that showed how their 2 pages of content worked just great with the vector search. When honestly, they could have just put the whole thing in the prompt. The problems with vector search are actually pretty serious in many real applications. So firstly, how do you vectorize things? You vectorize things by chunking them. Well, how can you chunk anything reliably? The answer is you cannot. Right? You can do a bunch of things to make it better. Like you can consider the structure. You can certainly do better than a naive approach, but you're going to get chunks that are cut off. And you've got half a bit of content. The LLM sees it, thinks it's not relevant, throws it away, doesn't know that actually the next section would make it crystal clear this was the thing. So that brings us to people trying things like hybrid search. Hybrid search is better, but it still doesn't solve the chunk boundary problem. So we firmly believe that the solution for RAG is agentic RAG. It's not the traditional pipeline. Pipelines for ingestion? Yes. Pipelines for RAG-driven inference, not so much. Because pipelines are going to be static, right? They're going to have a one-size-fits-all model. What we do instead is do agentic RAG. where we expose RAG tools to the model and tell the model how to work with the source. So the model, for example, can choose to do vector search, it can choose to do text search, but also when it hits a chunk, if it thinks that chunk is interesting, we give it a tool for zooming out. So we can say, it can say, give me the next chunk, or give me the previous chunk, or give me the parent chunk. And we found that significantly improves results. So, another example, if you look, say, at LangChain in Python, or I believe the object-related LangChain in Java, it's essentially legacy 2023 pipeline RAG. I mean, I think we didn't invent agentic RAG. I think there is a general agreement in the literature that this is the right way forward. But again, for anyone who thinks Python's the way to go, that might be a little bit of a shock that actually we're doing RAG in a way better way. Secondly, what if you have the problem of tool proliferation? Take RAG as an example. I think we've probably got 8 to 10 tools in our agentic RAG support with vector search, keyword search, zoom out, whatever. There's a few different things. All very well, what if we have, say, 5 different sources that we need, 5 different corpuses that the LLM might need to search? Well, now we're going to have a problem because, if we have 8 tools, any LLM will be reasonable. If we have 40 tools, any LLM will start to struggle. We've also got a problem that you would have hoped that we would have named those tools appropriately, which means now we're going to, for 32 of the 40 tools, we're going to have to use suboptimal names because they clearly can't use the same names. Or we're going to have to prefix them and waste yet more tokens on that. We have a solution for that, which is very valuable for RAG and beyond, that we call progressive or unfolding tools. So we would expose those tools, not as 40 tools, but as 5 tools with names like search product docs, search warnings, search alerts. And then when the LLM calls one of those tools, which it can obviously do pretty accurately, they then expand to have the child tools. This is why, with respect to Spring AI, we had to completely replace their tool loop because you need to control the tool loop completely. So we rewrite the tool call history to put in the child tools. This is actually in many ways a game changer. It means that it is with appropriate design, aware of any other framework of which that's true. So you have the ability as developers either to bundle things up under one tool or even do multiple degrees of nesting. Obviously, you're going to need more LLM round trips for this because it does need to go back to the LLM and say, I want to call this tool and get more tools. But the accuracy is significantly improved. So I think that's a very, very important capability that we have. Finally, one last thing, we are working on a memory system called DICE, which takes a lot of well-known prior art about patient memory, but goes a step further in that it structures the memory and helps tie it to existing entities, which I think makes it far more valuable in enterprise.
Is there a unit test framework alongside?
There is a unit test framework. In fact, there used to be a unit test framework. We don't have it anymore because the API is so simple to unit test that you can just use mock objects. Yeah, it's really good for unit testing. By the way, although obviously you can't unit test your LLM interactions, you can make a lot of mistakes with prompts. So like you can easily assert that your prompts have got the right stuff in them. And that will actually get you out of a whole range of problems. Yes, it's extremely unit testable. It also works well with string integration tests as well.
How do you decide the tool chaining? Like, do you deterministically configure the chaining which you just highlighted?
Between actions?
Yeah,
or,
actions, yeah.
Yes,
actions.
you do. So basically, you are implicitly configuring, deciding the chaining by specifying the type inputs and outputs of your methods, right? Like it cannot call one of your methods. So for example, it can't do the writer without having the horoscope, without having the relevant news stories. It can't go look up news stories unless it's got a horoscope. So we're using the types as signals for that. For fancier cases, you can define your own conditions And the conditions can be quite interesting. So for example, actions have costs, which can be dynamic. So imagine there's multiple routes to get to your end goal. And one of your costs is like spike like crazy because that system is under really heavy load and erroring all the time. You would rather it doesn't get called. It is a multi-hop version of getting around that versus calling that extensive system.
So again, the same question, like, do we rely on LLM intelligence to figure that out?
No, absolutely not. So yes, that is also a difference. So if you look at there are frameworks out there that do planning. So one of those approaches, for example, is Microsoft Semantic Kernel, uses LLM planning. We do not use an LLM for planning. So it's deterministic, will give you the same result every time, and it's based on the types. If you want to do something where you're leaving planning to the LLM, we have something called an agentic tool, which essentially where one LLM calls a bunch of other tools, and it's somewhat constrained. It's similar to what the supervisor pattern is called in Google ADK. But actually our version of it is marginally more deterministic because it can also be type of ways. But the planning is deterministic.
Yeah, I see AI is available in many of the lectures. So just wanted to know how we configure that AI object.
Yep. Okay, good question. Let me show you a real example. So this is from another one. If you work your way up to something a bit fancier in our examples, you'll get to the Urbot chatbot, which is designed to be used as a model of your own chatbot. This is using Embabel with a Vardin web interface. If you're using Vardin, we've got a bunch of components you can use for things like chat. But let's see, for example, how Urbot how does it know here that it's calling GPT 4.1? So we're looking with the Urbot code base, and this is a much more complex and it's a genuine application. It has built-in agentic RAG, by the way. So if you look here, you will see that we have a bunch of things for Urbot that are configured, including chat. So Urbot, chat, LLM, model, and temperature. So in the chat actions for Urbot, we've got the respond method. So here, this is an action. This one is annotated with can rerun equals true. Normally an action can only run once during an agent process. But if you're responding to user messages, you can run multiple times. Notice here also that while a lot of frameworks model chatbots as their own thing, as far as Embabel is concerned, the chatbot is just one type of agent process. So we give you a convenient conversation object that you can use in your chat process. But the chat process is sitting there and it can also respond to other events. So what if you have a chat with a user and some event came in that you want that agent process to respond to? No problem. So here, this, as I said, this is a genuine application, so it's more complex. But you've got the assistant message, context, AI with properties, properties.chat.llm. So in the real applications, we externalize it that way. Let's have a look at properties. Chat, as I said, Spring, you're going to find that, our conventions are very, very familiar. But the chatbot options here, we're able to simply, this LLM options type, which is core to the framework, is actually able to be externalized in Spring. So we've got lots of applications internally that use multiple models. And even that allow the user to change the models. By the way, you should not be using the same model for every interaction. If you're breaking it down, you should be able to look at what's the most appropriate model for each interaction. You don't need a big expensive model to do something that is small and simple. The thing that you probably generally do need a big expensive model for is your principal chatbot. because that is just a hard problem. So, we can make, I think, chat more predictable because we have this agentic tool notion where, right sizing the number of tools. But nevertheless, if you want really good results in a chatbot, throw as the best LLM you can afford at it. So here you can see this is literally the prompt that it's set up. This is a pretty fancy app. So it's parameterized in Ginger. So if you look at, for example, personalization.ginger, this is all using prompts. So all using templates. So for example, personas is the Urbot persona, and these templates are obviously able to use properties that come from Java. So let's just quickly go back to something else I want to show in chat options. And we're bringing in tools for the user, tools shared between all users. This is how we use the template. We go into this template renderer through rendering. And also in this case, we've got a kind of convenient get out of jail where if anything goes wrong, we just do alert the user. So here you can see the system prompt set to be very verbose. You can see in this case, this prompt uses memory. So it's showing the top 50 memories around the user that it's retrieving. We also by default put in the knowledge cutoff of the model if we know it, and the present date. That's really, really important. If you don't have that, you'll get inaccurate behavior. And then you can see the tools. So in this case, we've only got a very small number of tools. These two tools are progressive or unfolding tools. So the LLM knows if you want to get a user document, it calls that. Then it gets told, well, you can do vector search, you can do text search, you can do these searches. So it keeps the surface area pretty small.
You dynamically load tools with MCP or something?
Yes.
You guys don't reload.
We've got a lazy loading, yeah. And also progressive tool. So there's two kinds. The progressive tool is the more general form of the unfolding tool. Unfolding tool has a number of children that knows it up. Progressive tool gives you the ability to, when you hit it dynamically, like instantiate its children.
You have multiple actions that describe the same method signatures. So would that not create a conflict? How would Embabel choose which one to
that currently would be undefined. It will just choose one. So we've got an open issue for that, and we'll probably flag that as scenario. The way in which it would currently work is it would assess the cost of the action and choose the cheapest action. So actually that could be an argument for keeping it, where we could have two ways of doing it and say, correctly indicate the cost. But it won't error, it will just choose one.
So how coupled is it to Spring? I think I know the answer, but is it possible to instantiate it outside of the Spring configuration system just by creating objects?
It currently is coupled to Spring. We are fairly close to removing most of the coupling. Obviously, because most people using it are using Spring, and the Spring configuration is beautiful. Obviously, not going to change any of that experience. But there's much people in the Caucus team who are really interested in integrating with it. We're talking to them about this is one reason also that we've removed the unnecessary coupling.
Yeah, so maybe there are objects on one hand that anybody can instantiate a configuration system on the other where
Yes, currently, broadly speaking, you could do that. There's just a few places where you still definitely need Spring Boot cluster. But no, you could instantiate that.
Yeah, and that's probably annotations inside that are you need Spring to process them and stuff like that.
Yeah. So we are gradually
right. Well, that's.
I had a question, the way you showed example is not necessarily for an action to be tied to an AI. It could be so this can be very well used to create a pipeline of agents, actions.
Yep.
Without using AI at all.
Yes, we don't kind of position it that way, but you could. Yeah.
And what do you envision as the ideal use case or application of this framework?
Well, I think firstly, anything that you need to do with GenAI, if you're a Java developer, you should do in Java. And I think this goes to what this is probably the best framework we've got. So, you know, even if you're doing something really simple, like the show where you're injecting the AI interface, you don't need anything more complex than that. I would say the parts where the GOAT model and the planning really shines is for business processes where you want to make them more predictable, which is basically anywhere you can. So enable you to drop, Gen AI to create a bit of functionality, which just isn't possible without. Also, very, very powerful for creating chatbots using your Java estate. Okay, maybe one more question, and from someone who has enough questions. Sorry. Okay, I think we're done. Thank you.
Mr. Brad, thank you, Joe.